Today we are taking a look at this right here, the brand new 4th axis from FoxAlien. I'm going to be showing you how to set it up, get some basic tests done with it and give you my first impressions of it. So let's get stuck in. Now when you are purchasing a 4th axis, there are a few things to take into consideration and I've covered them all previously in this video right here. It touches on things like what to take into account, the different software you may need for working with 4th axis, which I will not be covering in this video. So I'll put a link up in the corner. I'll also link it at the very end of the video, so definitely check it out because there's a lot of useful information in there that, as I say, I won't cover in this episode. But let's move on and get everything set up. Now the very first thing you're going to want to do is get everything unboxed. The box will contain your FoxAlien 4th axis, visually inspect it, make sure everything looks okay. You'll also have 2 cables to allow the NEMA 23 closed loop stepper motor to run. You'll have 2 locking bars. This allows you to tighten up the jaw onto your material, as well as a bag full of some nuts and bolts to help hold the 4th axis down to your bed. And obviously the instructions to walk you through the setup. Let's quickly take a second to look at the 4th axis and understand a bit more about it. Now there are essentially 3 parts to this. We've got the driver mechanism, we've got the tailstock, and we've got the base plate that everything is fixed down to. Now this is where all the power comes from on the 4th axis. Obviously we've got the NEMA 23 closed loop stepper motor driving the chuck over here, and the chuck is what holds your material. You rotate it in opposite directions to either open or close the jaws up on this side of the unit. Now the jaws themselves have multiple teeth in here. These can actually be taken out, flipped around and reversed. What this means is you can either hold solid stock from the outside by clamping on the outer edges, or you can clamp things like pipe by coming out from the inside to grip the inside of the tube. On the right hand side we have the tailstock, and this is for basically tightening up and clamping the material. So whilst this will grip it from the outside, the tailstock allows you to put the horizontal pressure against the stock to hold it in place in the jaws. It also plays a crucial part with helping to keep it horizontal to the CNC machine so that everything machines steady. And finally you've got the base plate. This has multiple fixing positions, so you can actually move the driver unit left and right. You can also move the tailstock left and right to give you the maximum amount of space depending on the machine you are installing it on. You can actually unmount both of these 2 pieces as well and just install it separately onto your spoil board should you want to do much longer pieces than the base plate allows. Now I'm quickly putting this clip in, which was actually recorded later on. So yes, this is designed to fit on a 400 bed and therefore it limits the length of the stock that can actually go into it. But I've modelled and developed these 3D connecting plates that will go onto the end of the base plate. You'll see these in use a little bit later on, but I wanted to show them now just to highlight that this can do longer pieces and basically still have a good stable base to work with. Now, the 3D files and printed copies of these will be available on my website should you want them, so go and check them out. But let's carry on with the rest of the video. Now, a really nice feature when using the base plate is the tailstock is actually installed on a linear rail. What this means, well, basically, movement is extremely easy and silky smooth, making your life much easier. On some 4th axis, this just runs in the grooves and it often jitters when you're trying to move things back and forward. But as you can see, this is just making life very easy, very smooth, and a really nice addition to the 4th axis. In terms of what the 4th axis can take, it can obviously machine wood, but it will also machine metal as well due to the power of the stepper motor. And you can have both square stock or circular stock in either option. So in terms of key details about what this can actually hold, well, from the center point on the tailstock down to the base, we're looking at about 48-49 millimeters, so just shy of 2 inches. If you are talking about square stock, take into account this needs to be the diagonal measurement, not the side measurement, because that is the widest part of the material. Now, in terms of what it can actually hold, I will put some details up on screen for the maximum measurements of the jaw itself. One thing you can do, obviously, is take the units off the base plate and raise them up to take thicker stock. Obviously, this does depend on what your machine is capable of handling, though. And it's not just about the height of the Z axis, it's about the overhang as well. So you need to take into account your machine setup to allow what it can take in the maximum in terms of the height and the overhang with it. Now, in terms of what the jaws can actually hold, there are ways to get around this in terms of the maximum holding size of the jaws versus the maximum material that it can take. For example, what I've done here is fixed a block of wood so that the jaws can clamp onto that, but that allows a larger revolving of the material that can be fixed. This is probably a bit oversized for this particular machine, but it gives you an example of ways that you can get around the maximum diameter clamping versus the maximum size the fourth axis will take. Now, as mentioned earlier as well, these pieces can come out of the chuck itself and be turned over, so you can clamp from the inside or the outside. So there are different measurements to this for what it will hold. Now, when you come to take these out and revolve them around, there is typically an order that they come in and out of. You may just be able to see there are little lines on the back of these, and these basically line up with the thread on the chuck itself. So take note of when you take them out, because they need to come out in a certain order and go back in the same order to make sure the threads align when it is being chucked up. If you are in any doubt and have never used a chuck like this before, the instruction booklet does give you very clear guidance about adjusting the jaws and the order that they need to come in and out of, depending on whether it is forward or reverse mounting. Now, when it comes to actually running your fourth axis, this can be done in two different ways. Typically, most people will run this on the x-axis as we have it set up here. What this means is the y-axis stays fixed in position, and then the x-axis moves left and right to do your machining. However, you can do it on the y-axis as well by turning it round and installing it this way instead. And in this scenario, the x-axis stays in a fixed position, but the y-axis moves back and forward to do the machining. Now, some of you out there will be looking to purchase this rotary for a 400x400 machine, but may be worried about the maximum length you can machine, because obviously as it sits inside here, you are limited by the axis on each side. Well, this is one way to get around it. These type of machines often have dead space at the back, and that is the perfect place to take the chuck and the stepper motor. So by machining on the y-axis as opposed to the x-axis, it means you can fit this in and utilize the full length. Obviously, you can unmount this and put it directly onto the bed, or use something like the extension tracks and allow the tailstock to move off and give you that maximum machining area. The only thing you need to do is make sure you've got enough clearance between the top of the fourth axis and your Z assembly. This is about 95mm high, so just short of 4 inches. So that is the clearance that you will need underneath in order to fit this in. But this is a great way to be able to get maximum length out of your fourth axis, even on a 400x400 machine. Now, regardless of whether you are running it on the x-axis or the y-axis, there is one crucial rule you must follow, and that is that the fourth axis needs to be perfectly parallel with the axis you are running it against. So in this scenario, running it with the x-axis, this needs to be perfectly aligned with the x-axis at the back. Now, there are a couple of ways to do this depending on how you are mounting this to your bed. If you have something like the FoxAlien XC Pro that has multiple inserts across the bed, then those inserts should align extremely closely to how parallel the x-axis is. So by installing it in those inserts, it's going to put you in a very good position. If you're doing it on something like the XC Ultra that I have here, there are a couple of ways to get around it. The first thing that you could do is just put something like a V-bit into the machine and draw a line across your spoil board, and that will give you a perfectly parallel line to align the fourth axis against. An alternative option is using something like your own threaded inserts. These, for example. What you can do is just create a very simple program to drill a couple of holes aligning with the holes in the base plate. Obviously do this on the x-axis, fixing your threaded inserts into your spoil board, and when you come to fix it into those, it should guarantee that the fourth axis is then parallel to the x-axis it is going to be running against. Now, with fixing it down, obviously, as I mentioned, you can use things like threaded inserts. You can screw this down to the bed. You could even just use clamps for ease. So as I mentioned at the start about drawing a line across the bed, if you want to do it in a quick way, it could just be aligning that to the line you have put in place, bringing in clamps and holding it down via the base plate. So you do have a couple of choices of mounting this to your machine, but as I say, the crucial thing is just making sure it is parallel with whatever you are doing against the axis. Now, when it comes to connecting the fourth axis up to your machine, this could not be simpler. The two cables provided have different size connectors on them, and they will only go in one way into the relevant ports on the back of the stepper motor. So take the cables, you keep the clip on the outside, push that into position, and it should just click in once it's in position to hold it nice and tight. There we go. Similar thing with the other cable, that will only go in one way. There are two little prongs on the outside. Push that into position and it should click in the same way to hold that in place. Take the connectors from the other end and connect these to the back of your FoxAlien control box. If you are using a different controller or running this on a different machine, you may just need to confirm that the wiring order is in the same order as what you are aligning it up to. Now there is one setting on your machine you need to check, and this is the $103 Gerbil setting. This is about the rotation of the fourth axis and how far it turns each single step. So you need to go in, adjust your 103 to 44.445. And this should mean that the rotation is accurate. So a 360 degree rotation should result in 360 degrees on the fourth axis. Now, when you are using any stock on a fourth axis, a crucial thing is to define the center point on the material. It doesn't matter if it is circular or square, you still need to find that center point because it helps for the tailstock to contact and make sure that it revolves centrally when it is rotating. Now, square is pretty easy. You just take the stock and you can draw diagonally corner to corner, and where the center point is, that is the center for the material. With the circular stock, it is a little bit different. You can get 3D printed jigs like this that you just basically place on there, take something like your pencil, draw a line across it, rotate it around, draw another line, maybe do it just once more. And what we can see is that where all those lines cross over, that is the center point for the material. So very easy to do, but you do need to make sure this is accurate to guarantee that when it is rotating, it's rotating centrally. Now for ease and speed on this video, I've done exactly what I said earlier. I've machined a line into the spoil board to help alignment with the x-axis, and I'm just holding it down with clamps. And again, I'm just using a small piece of softwood stock that I'm going to put in here for the test cut. I'm just going to place that in, tighten it up. With it being softwood, you can do this by hand, but obviously you've also got the locking pins that come within the kit. We're going to pull the tailstock in, lock this off. You need to make sure it is aligned to that center point on there. Lock that in position, and then we can just tighten this up if we want, just to add a little bit of pressure, and lock it off with the bolt on the back. Now, a really crucial part about setting up your fourth axis is when you bring the bit over the top of it, it needs to be dead center to the material. Now, hopefully the camera just picks this up. What I've done now is just put a little scratch in the top of the unit. Then this was 31.75 millimeters in from either edge, which should mean that it's dead center to the stock. So I know that when I bring my bit over, I can hover it over that, align it with that mark before moving it over to the material to start the job itself. Now, if you want to be sure that your rotation is correct on your fourth axis, you can do something like I've got here. Just stuck a piece of tape down to the chuck and put a pencil line in line with the scar that I made earlier. Now we're going to tell these settings to rotate this around 360 degrees, and that should come all the way back to the start once it runs. So this will do a full rotation, comes back round, and that should perfectly align back up like we have there. Now when it comes to doing the zero for your job, treat it like you would do with a flat job. It's about finding the starting position and then touching the top of the material. So the way I achieved this was jogged the y-axis down and brought the bit directly over this little metal mark that I made on the top here. That guaranteed it's central with the fourth axis. I then jogged it over to the right hand side on the x-axis till it aligned with the center of the material there, before lowering the Z down just so the tip touches the material. So I know this is now in the correct starting position. I can reset the zero in my software and get the job running. So I started my testing off really simple. 3 V grooves in the cylinder. The reason for this is when you're using a new device like a fourth axis, you want to start simple, make sure everything is working as expected. I was looking for clean, consistent cuts, full 360 degree cuts, and making sure that there's nothing wobbling in it, and it came out great. I then stepped it up and engraved my name into another cylinder. The reason for this, I wanted to see how we handled diagonal cuts as well as curve cuts whilst it was rotating, and again it came out really clean. I then stepped it up really big. This is about 2 foot long. Now again, I wanted to see how it handled larger pieces, because if you've got a bigger machine like this, well, you want to do bigger pieces on it. Now, FoxAlien advise you can disconnect the driver and the tailstock and mount it to your bed separately. I wasn't keen on that, so what I've done is prototype some 3D printed connected plates, and you can put one on, put two on, depending on how big you want to machine. They connect really tight. This is basically a prototype. I'm going to refine it slightly, but all these files will be on my website to buy if you have a bigger machine and want to do bigger projects like this, so go and check them out. But now I'm about to move on, put a piece of brass in this, do a very simple job and see how it handles it. So I've fitted a 3mm end mill with 4 flutes with a DLC coating. This is ideal for things like aluminium and brass, your soft type of metals. All I'm simply going to do is face the surface of this 25mm. So we'll get it started. So it's just finished up machining the brass. Now at the end of the day, I only did a short section and took shallow passes with it. And that is basically because I didn't actually need to machine anything from brass, and it is not cheap, so I didn't want to waste too much of it. But it does prove that it could do it, and I could have gone a lot more aggressive than what I did with that. Obviously, as well as brass, it will do your other soft metals as well, such as aluminium. So first impressions from this, well, it is looking a very solid build from FoxAlien. Powerful with the NEMA 23 closed loop stepper motor, rigid build across the whole thing with the solid base plate, and I genuinely love the linear rail sliding feature in the middle of it. It just makes moving your tailstock so smooth and so easy. So brilliant job from FoxAlien for delivering this, and it's going to make a brilliant accessory for your CNC setup. If you are looking at purchasing this, there will obviously be links down in the description area that will always take you to the best available price. If you've got any questions, obviously let me know. I'll do my best to answer them, and keep an eye on social media because I'm probably going to be doing a bit more testing with this, and maybe things like full 3D relief carvings, which I have no doubt are going to come out brilliant. But thank you all very much for watching. Final thanks as always goes to my patrons, and I will see you all on the next episode.